before, I'm recording different examples in different classes so that you have more help at home if you need it. So. And of course, you can always come talk to me. So. The area of the region between the graph here, the x-axis, okay, the line x equal 1 is a vertical line whose x-coordinate is always 1. A vertical line whose x-coordinate is always 1. For years, I struggled. Whenever I'd read a problem that said x equal 1, I couldn't remember this way or this way until suddenly, like, the most obvious thing occurred to me. I don't know why it didn't occur earlier. It's a line where the x-coordinate is always the same. The x-coordinate is always 1. The only way to draw that kind of line is up and down. Question? Cool. So I draw a picture. So I got x equal 1, x equal 2, the x-axis, and this curve. Well, here's where my quick and fast method comes into play. I don't try to remember how to graph a cubic. I just do something a lot simpler. I remember a graph is just a bunch of points. And I'm like, oh, easy. The only x-coordinates I care about, I don't care about the graph really. All I care is that I'm between x-coordinates of 1 and 2. Well, if you plug any number between 1 and 2 into this, something very nice always happens. Like what y-coordinates am I always going to get when I plug in x's that are between 1 and 2? Positive. So here's my very technical sketch of that graph. Perfect. Okay? Really? It doesn't matter. It doesn't matter. All I care is that all the y-coordinates are positive. And now I know the integral. It looks like this. Because it's top minus bottom, this would be subtract 0. So there you go.
Why can you do negative?
So just check a few. What's 1 cubed?
Oh, yeah.
No worries.
Yeah.
There you go. You good now?
The thing is, like, why can't we just
Oh.
kind of like go down, like, past the...
This curve, no, it's a good question. Look. This curve definitely has y-coordinates that are negative. I guarantee it. Just not between x equal 1 and x equal 2. So I don't want to spend all that time I learned in a previous class how to like graph the thing. Who cares?
Yeah, okay.
All I care is that for this space that I'm interested in, it's positive.
Yeah.
Is that your question?
Yeah.
2 points.
How do you know that 2 goes on the top of the integral?
Oh, that's convention. Meaning somebody decided long ago that the normal way of integrating will be from left to right. Likely because the person who discovered it read English and reads left to right. We'll learn later that if you do it the other way around, there's a way to handle that, but it can kind of introduce inadvertent mistakes, so best to do that. Is that your question? 2 points. Very good. So, finish the problem, go. Okay, just a suggestion, look. Everybody look at the board. See me look up a minute. Okay, when I first taught this concept, I went to the trouble of writing everything out so that hopefully no one would get lost. But we're further along now, so you can do more in your head, and it really is easy to just do it in your head. When I have an integral and inside I have 2 or more things adding, I really don't, either way is fine. I personally think it's better to not go to the trouble of like integral and then another integral. Just say, I need this antiderivative, so I'm just going to do them separate. 4 is just a multiplier, write it down. That antiderivative, x to the 4th over 4. Antiderivative of 2 is 2x. And then put the bar, like that. To me, that's faster. Then proceed from there. So Raise your hand if you got it to work. Show your hand. Hands up. Who got it to work? 2 points. Okay. You don't want to talk about anything. You didn't want to talk about anything other than the difference between regular calories and digestible calories.
Oh, I'm so
Okay. Inside joke. Funny. That is funny. You're right. I didn't notice. Pun not intended. So, go to 8, please.